Hello, everyone. I'm Amirmohammad Kazemeini. I'm studying Master of Science, Master of Computer Science at the University of Western Ontario. I'm also an automation intern at Vector Institute. Actually, my internship was so related to Gursa Heights, so I chose to talk about my part of my thesis, which is related to intersection of AI, NLP, and psychology, to be specific, mental health. I'm particularly interested in predicting people's personality based on their textual data. And this is the part of my work which is submitted to ICDM 2021 and is currently under review. Okay, so I first, let me give you an overview. I first introduce the task of personality trait prediction. Then I go to the background study and describe the data sets. And I give you an overview of our approach, and then I explain the results, and last of all, conclusion. Okay, so what is the task of personality detection? Personality actually refers to individual differences in characteristic patterns of thinking, feeling, and behaving. So in order to evaluate that, we use the most famous personality test, which is known as Big Five or Ocean, which assess your personality based on 5 categories: your openness to experience, your conscientiousness, which is actually the personality trait of being careful and diligent, the extroversion, how outgoing you are, the agreeableness, how you cope with people with different ideas, and neuroticism, which is describe you how moodiness you are. And studies has shown that there is a correlation between how you think and how you put your thoughts on paper and your personality. And we use stream of consciousness, or in other words, expressive writings, which is the type of essays that you put your thoughts on the paper, and we analyze that essays to predict your personality. Due to the diverse practical applications, a large interest has grown for automatically personality detection. And the applications are, for example, the mental health area, like detecting depression or suicide ideation, which is so correlated to neuroticism rate, and or job screening, which is so common nowadays. And the most common application is recommender systems. For example, look at these 2 different advertisements. For example, if you want to advertise cosmetics for an extrovert person, it's better to use the left-hand side picture, and along with this text, dance like no one's watching, but they totally are. And if you want to advertise cosmetics for an introvert person, it's better to use the right-hand side picture, and along with beauty doesn't have to shot. And studies has shown that if you do this, if you follow this approach, you get more profit and higher sale. Okay, so for the background studies, all the following papers report the results on essays datasets, which is some kind of stream of consciousness essays, which is derived from students from University of Texas at Austin. So there were several papers before 2017 that they used handcraft features for detecting personality, but the features they used were designed for a specific type of dataset. So this paper started the hype in pure deep learning based personality detection from text, and they got the state of the art at that moment. They actually used pre-trained version of the word to work, and they use one-dimensional convolutional neural network and several max pooling layers to get the document vectors, and they used Mayer's feature to concatenate it with document vector. Mayer's features are actually some kind of psycholinguistic features. For example, they count the number of self-reference, the number of swear words, the number of verbs, adjectives, and so on. And all of them are normalized. And they added fully connected layer and softmax layer to get the result for this binary classification task for each of the traits. Okay, after that, our work started with using contextualized word embeddings. Until 2020, the previous paper were holding the state of the art in that data set. So we to try to divide essays to subdocuments, because we were using BERT-based models, and BERT-based models had some restrictions in the input side. So we divided the essays into subdocuments, and after that, we used the last 4 hidden layer of BERT, because as it is explained in original BERT paper, the last 4 hidden layer of BERT gives you the best accuracy if you do not want to fine tune the BERT. And after that, we got the features, we averaged the vectors over the vocabularies, and we concatenated our features with Mayer's features, as I told you before. And we used BagSVM to get the result labels for subdocuments. And after that, we used majority routing to get the final prediction. And we improved the state of the art by more than 1%. After that, we tried to improve our model even more with somehow using different other approaches. For example, we replaced the SVM with fully connected layers. We somehow enriched the psycholinguistic features with some readability and some sentiment analysis features. And we tried to truncate the essays rather than dividing it into several parts. We took the most influential part that plays the best role in the final prediction. And we also tried different BERT-based models like Roberta, BERT-based, BERT-large. And after tuning all the hyperparameters, we achieved higher accuracy. So what is the problem? Actually, we are getting the accuracy is increasing and everything looks fine. But as the model gets deeper, it becomes less interpretable. So the divergence occurs when we want to make the model deeper because it becomes less interpretable, and that's the problem. And the other problem is that we cannot justify some of the results. For example, this is the result we got from the ICDM 2020 paper. And when we use BERT-based plus MLP, we got the state of the art. But when we concatenated the BERT-based features with some other psycholinguistic features, we got lower accuracy, and we couldn't justify that. And also, we couldn't justify why we got lower accuracy when we use BERT large instead of BERT base. Okay, so to find the problem, actually, we tried to use psychological discoveries instead of training everything from scratch, because currently deep learning models train everything from scratch, and they do not use, for example, the psychological discoveries that has been achieved here. Okay, so we introduced two mini data sets. One at the baseline sentences for both ends of the personality trait spectrum. For example, for each of the personality traits, for extroversion with label 1, we introduce I'm extrovert. For extroversion label 0, we introduce I'm introvert, and so on. We also use BFI statements. BFI statement stands for Big Five Inventory Statements. Actually, when you want to assess your personality traits, you fill a questionnaire. They include some kind of questions like, I'm someone who is talkative, and you rate yourself from 0 to 5. And based on that and some calculations, you get your final results. Okay, so we use the simplified version of the statement, and we assign trait and score for each of the statements. Then we fed both BFI statements, which are identified by X and circles, and the baseline statements, which are identified by plus and star signs, which are indicated also with capital V here in the legend, to BERT-based, which got the state-of-the-art result. And then we applied PCA, and here's the visualization of the result. What we expect to have the obvious clusters, for example, but what we see is messy and relatively random points. So we can conclude that maybe the BERT base is not the best approach and appropriate word embedding for psychological use in personality detection. So in order to fine-tune that, our goal is to improving the representation. So we first introduce these two data sets, then we apply pair-making approach. Okay, so the pair-making approach follows this algorithm. BFI statements from a similar trait are paired. You can see here. And the label is 1 if the labels are similar, and the label is 0 otherwise. So for example, for BFI statements, we have 85 questions in self-assessed questionnaires, but we make the pairs, we get 681 pairs actually, and we divided them into training and validation sets. So we got the insight from SimCLR, and for example here, regarding extroversion, for each of the spectrum, we expect corresponding BFI statements that are indicated here. For example, I'm talkative and I'm outgoing, attract each other, their embeddings, I mean. For different, for opposite statements, they should repel each other. For example, I am reserved, its embedding should repel I am talkative representation. So in terms of textual data, we follow the approach of infer-sent architecture, which is derived from Siamese architecture. We fit the sentences of the pairs into the BERT model. We get the word embeddings from layer 11 of the BERT, and we use the Siamese PyLSTM. And after applying max pooling, get some results here. And after merging these two representations, we apply clustering to find if these two statements of the pair are similar or not. After training this fine-tuning architecture, we get the final representation after the max pooling layer. So let's see how is the result. Okay, in order to evaluate a result, we should use some specific evaluation metric that we introduced here. So, and please keep in mind that the baseline sentences are not used for training, and they're just used for evaluation. So the BERT label here for a specific statement follows this formula. The C stands for cosine similarity between statements and this corresponding baseline statements. For example, for extroversion, we have I am an outgoing person. Baseline sentences for trait extroversion, and 1 is I am extrovert. And baseline sentences for trait extroversion, and 0 is I am an introvert. So we based on its cosine similarity and the closeness to its baseline sentence, we assign 1 or 0. And we can see here that our model could improve the accuracy in terms of PRED label. And the BERT, an average version of the BERT was used in the state-of-the-art model in the ICDM 2020. So you can see here also that the categories can be divided by even a straight line. You can, for example, let me show you, you can easily divide the categories by a straight line. So it seems that our model is working very well. And actually, when we divide it into two categories, you can see that its corresponding baseline statements are in the correct category. Okay, so this is the comparison before applying the fine tuning and after applying the fine tuning. You can see that the model, for example, for their blue points, they're easily clustered together, but here there are somehow random dots. We also try to utilize pre-trained version of the sentence BERT to see if there is any pre-trained model that can improve our work representation or not for personality detection. Actually, we use the sentence BERT architecture, but we didn't fine-tune the sentence BERT architecture, but we just use the pre-trained version. And we use the sentence embeddings from after the mean pooling from the BERT-based variations. And here we can see that after trying different variations of sentence BERT architectures and testing them on PRED label accuracy, we got about 100% accuracy for natural language inference version of the Roberta Large. And this accuracy you can see here is when we replace the BERT base with natural language inference version of the Roberta Large in the ICDM 2020 paper. We improved the state of the art for essays dataset. And you can see how beautifully all the marks are clusters before even the fine tuning anything. So we can conclude that, in conclusion, I give you the result for our final experiment. The question is there any correlation between essays accuracy using state-of-the-art model and PRED label accuracy while we try different sentence BERT variations? And yes, you can see here. Yes, there is a significant correlation that we can conclude, significant correlation. And we can conclude that when we want to choose a word embedding, it's better to try it on BFI statements using PRED label before testing on real world datasets. Which higher accuracy on PRED labels means that more interpretability and probable more accuracy in real world datasets. Okay, and here's some references that I used, and thank you everyone. If you have any questions, I'm happy to answer.